Hello, ladies and gentlemen. We are going to be taking our final exam via Edpuzzle. So I'm going to get started. After you answer the question, the video will continue on. Oh, here we go. So I'm going to give you some examples. I'll talk you through some of these problems. So let's just start off with how many protons, electrons, and neutrons does carbon-14 have, ladies and gentlemen? So how many protons, electrons, and neutrons does carbon-14 have? Well, let's take a look, ladies and gentlemen. So carbon-14 is made up of carbon, which we can see right here. The protons, ladies and gentlemen, are positively charged. And that little number right there, that's the number of protons. The electrons normally equal the number of protons in a neutral atom, okay? And the neutrons plus, the protons, so that's the protons plus the neutrons will equal the mass. So in this example, the mass is 14 because the 14 in carbon-14 means the mass. So the mass is 14. The number of protons is 6. So in this example, the answer would be 8. All right. So we have protons, electrons, and neutrons, and that's what these next questions are going to be all about. So let's take a look. All right, here's the first one. How many protons does neutral chlorine 37 have? And you can see right here, there's chlorine. So how many protons does chlorine have? How many electrons does neutral chlorine 37 have? So how many electrons? Next, how many neutrons does neutral chlorine 37 have? And finally, let's just take a look at the next one. So on this one, you can see that we're working with chlorine 37, okay? As you can tell by the number 37, that's the mass. And then it has a -1 charge. So the charge is -1. So the first question is, how many protons, ladies and gentlemen, how many protons does chlorine 37 have? Now, what is the number of electrons for chlorine 37 ion? So the ion with a -1 charge has how many electrons? Next question, what is the number of neutrons of chlorine 37 ion? So how many neutrons will this ion have? And finally, what is the mass of chlorine 37 ion? So what is the mass of the chlorine 37 ion? All right, so now let's move on. This is an example, and I'm going to do a couple example problems for you as you're taking the exam. So what ion has 7 protons and 10 electrons? Well, in this case, nitrogen has 7 protons. But nitrogen normally will have 7 electrons, because remember, the protons equals the electrons. But in this case, there's 10, which means there's 7 protons and 10 electrons. So we're dealing with nitrogen. We can say there's more electrons than there are protons. How many more? There's 3 more negatively charged particles, which means the ion we'll be talking about is nitrogen 3- ion. Okay, so let's take a look at our first problem. What ion has 20 protons and 18 electrons? Next one, what ion has 16 protons and 18 electrons? All right, let's take a look at this next one. We're working with how many different atoms there are in a molecule. So this question says, how many carbon atoms are there? And in this case, we can take a look and say, well, there's the carbon, That's hydrogen, and this is oxygen. This one has 6 carbon atoms, ladies and gentlemen. So the answer would be 6. All right. So let's work out some of these problems and see how you do. Okay, the first question says, how many potassium atoms are in potassium phosphate? The next question says, how many oxygen atoms are in scandium nitrate? All right, now let's take a look. How do you write formulas? Okay, so let's just take a quick reminder. I'm going to go over this with you. So when we write formulas, we're looking at how do we write things like water, right? Or sodium bicarbonate. So we want to write out these formulas. And that's what a formula is, this type of a compound. But what we want to do is, how would you write a formula that has a sodium and a sulfur? Well, let's take a look. First thing we need to do is balance out the charges. You can see this one has a -1, and this one has a -2. The best example I can give is that we have cookies, and this cookie has 1 chocolate chip. This cookie over here has 2 chocolate chips. But what we want to do is balance out the chocolate chips. So what are we going to need? Well, we would need 2 cookies, because each one of these cookies over here comes with just 1 chocolate chip. And conversely, let's just say that each cookie came with a +1 charge, right? A sodium charge. That means you'd need 2 sodiums for every 1 sulfur. So the formula here would be 2 sodiums for every 1 sulfur, because in this case, you'd have a +1 and a +1. And in this case, it's just a -2. And a +2 would equal a -2. Those charges cancel, and there we have a formula. Same thing would happen here. Here we have magnesium. Magnesium's here's a +2. Nitrate's a -1. Those charges don't balance. So we have cookies with +2 charges over here and cookies with -1 charges over here. And we have to balance out the charge so that they cancel out. So we're going to need another -1 cookie. So now we would have 2 of these cookies for the -1 charge, or of those nitrates, and then 1 magnesium. And our formula would say, well, we have 1 magnesium and we have 2 nitrates. Now we can't just write it like this, because that would say 32 oxygens when it's NO3. So we have to put brackets right around this thing. So pay attention to all those little caveats when we answer these next questions. Good luck. So what is the formula when the following ions come together, ladies and gentlemen? What is the formula when these following ions come together, ladies and gentlemen? Good job. Hopefully you guys did well on that last little part of building molecules. Let's take a look, ladies and gentlemen, at the next question. Sorry about that, ladies and gentlemen. It skipped 1 slide. I must have double-clicked. So this is the next question. What is the formula when these ions come together? Fe3 plus and CO3, 2 minus. What would the formula be? Okay, let's take a look at the trends, ladies and gentlemen. Trends. So let's take a look at atomic size. Now, we talked about atomic size previously. So these right here are orbitals. So we have energy level 1 or orbital 1, orbital 2, 3, 4, 5, 6. Those would be the orbitals, kind of like there's orbital 1, 2, 3, 4, 5, 6, etc. And flying around these, we have electrons. So it'd be like 2 electrons in the first energy level, 1, 2, 3, 4, 5, 6, 7, 8 electrons on the second energy level, etc. So again, energy 1, 2, 3, 4, 5, 6, 7. Now, as we go down the periodic table, the atomic size gets bigger because we have shells. Because energy level 1 must be inside energy level 2, which must be inside energy level 3, inside energy level 4, etc. So as you move down the periodic table, size gets bigger. And as you move across the periodic table, ladies and gentlemen, the size gets smaller. And the reason is that you're increasing the number of protons. So the more protons you have, the more pull, or like magnets, right, that are inside of the atom, which are going to make the atom get smaller. So you have little tiny atoms over here. And then as you move across to the left, they get bigger. Now, that deals with size. Electronegativity is how easily an atom can hold on to electrons. Well, the electrons on big atoms are way out here, away from the nucleus. But on these little tiny atoms, the electrons are really close. So, in terms of electronegativity, as you move across, you increase the electronegativity of an atom, or the ability of an atom to hold on to its electrons. And as you move down the periodic table, the atoms get much bigger, and it's much more difficult for atoms to hold on to electrons. Okay, so the electronegativity decreases as you go down the periodic table. So that's what we'll be working on today, different trends. So let's give it a shot. So ladies and gentlemen, which atom is smaller of these three that are circled? Lithium, carbon, or oxygen? Which atom is smaller of these three that are circled? Beryllium, calcium, or barium? Now let's talk about electronegativity. Which atom is more electronegative? Calcium, gallium, or bromine, ladies and gentlemen? Which is more electronegative? And as we move down a column, which atom is more electronegative? Fluorine, bromine, or astatine, ladies and gentlemen? Which is more electronegative? Okay, perfect. So let's take a look at valence electrons. Valence electrons, ladies and gentlemen, are the outer electrons. So valence is the Latin word for outer. It's not really, but you could imagine it is, okay? Valence is the outer electrons, outside electrons. So in this case, these electrons right here are the outer electrons, the ones on the outside. I could probably draw a better circle, right? No, I like that. I like the way I did it before. So these are your outside electrons. Those are your valence electrons. In this case, this one would have 7 valence electrons, okay? So you can tell the valence electrons because we take a look at these columns. So you have the first 2 columns, 1 valence electrons, 2 valence electron, 3, 4, 5, 6, 7, 8 valence electrons as you move across. Although obviously helium only has 2 because there's helium right there. But all the other ones starting at neon in this column have 8. And those would be the electrons that are on the outside. We ignore these in here when we're talking about valence electrons, all right? So valence electrons are the outside electrons. They're located on the outside. And then let me just give you a quick glimpse at Lewis structures, ladies and gentlemen. So this would be the Lewis structure of chlorine, because chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. And there are its 7 valence electrons, 1, 2, 3, 4, 5, 6. And that would be our Lewis dot structure. Hopefully, ladies and gentlemen, you do well on this next little section. So let's go for it. How many valence electrons are there in phosphorus, ladies and gentlemen? Which is the correct Lewis structure for sulfur? Okay, that's going to move us straight into functional groups, ladies and gentlemen. So let me go through some of these functional groups. A functional group is a little part of a molecule that kind of sticks off to the side. So what would be the functional groups here? Well, let's take a look. We learned all these different ones: amine, aldehyde, alcohol, ester, and I've given them to you all right here. The only ones I haven't given to you are the alkane, alkene, and alkyne. Remember, that was a double bond, triple bond, single bond all the way through. All right. So what we need to do is we're going to find out what are these functional groups. So let's just take a look at this red one here. So this has a nitrogen in it, and there are only two functional groups that have nitrogen, those two at the bottom. So which one do we have? Well, it's either an amine or an amide. Amide has a double bonded oxygen, right? Do these have double bonded oxygens? Nope. So that means that this one here is an amine. Let's take a look at the green circle. Which one of these would be the green circle? Well, it's actually not here, so be ready for it. This one is a carbon ring. All right, I don't even see it up there. Oh, it's hiding behind my name. There it is. All right, so this would be a carbon ring. All right, I didn't need to put it there because don't need a drop. And this last one, there's a nitrogen. And look, double bonded oxygen. Which one do you think this one is? This little functional group here. Yeah, it's an amide. Well done, ladies and gentlemen. You are going to ace this next section of the test. So let's go for it. What is the name of the functional group circled below? What is the name of the functional group circled here in red? And what is the name of this functional group, ladies and gentlemen? Excellent. Now, this is a carbon chain. And my question is, how many carbons are shown in this structure below? How many carbons are there in this structure? All right, so let's get busy. Let's get down to chemistry. We're gonna be talking about the mole. And we're not talking about those little fuzzy furry animals. We're talking about the mole in chemistry. And all I wanna know is, ladies and gentlemen, what is a mole when we're talking about chemistry? I'll let you know that a mole is a huge number. So here we go. How many are in 1 mole? So if you had a mole of donuts, ladies and gentlemen, how many donuts would you have? All right, so what we're gonna do now, we're gonna get into our conversion factors. Let's see what we've learned. So I'm not gonna sit here and explain this because we've just done this for the last like 4 days. This should be fresh in your mind. So answer the question, please. Which is the correct conversion factor that we're gonna use, okay? So our conversion factors, remember, whoopsie daisy. Our conversion factors, ladies and gentlemen, are gonna go right here. So the question is, which one of these two conversion factors, A or B, are going to go into this problem? Whoops, I shouldn't cover that up. And this is our problem right here. Whoops, there we go. Man, that's the straightest circle I've ever seen. You know what, I'm gonna go for it again. Let's see if I can do a little better. Oh yeah, and we're gonna swoop right by. So here's our equation right here. Sorry to waste your time. What is it? Which goes in there, A or B? All right, let's take a look at the next one. Did I do that one twice? I must have. Oh, no, I didn't. Oh, I was clicking the wrong place. There we go. There we go. So the next question says, okay, we're going to read the question below. And I want to know, what are you solving for? So what are you trying to find in this question, ladies and gentlemen? Next question here, what are you asked to convert from? So what are you know what you're looking for, so what are you trying to find out about? All right, so what are we using to convert? What are we converting from? Okay, we put at the beginning of this. And lastly, if you were to solve this problem, which conversion factor would you use? Now, I suggest you take out a pencil, paper, something, and work this one out a little bit because I haven't given you anything. You're going to have to work this one out. The next question, what is the answer to this question? So read this fruit basket question and tell me what is the actual answer, okay? This will have a number and a word, like you'd say, oh, there's 22 cars or 18 bicycle wheels. I want to know what is the actual answer to this problem. And lastly, ladies and gentlemen, there is one last question that is left. And you just have to answer this final question. The answer to the final question, ladies and gentlemen, is just find your true happiness. I hope that you guys did well on this final. I'm hoping everybody gets an A because it has a possibility to boost your grade about 10%. So good luck, and I hope you do well. Hope you did well.